Hi everyone. Today we're going to start talking about sedimentary rocks. So for this part of the lecture, we are going to go over the different processes that produce sedimentary rocks, as well as learn how to describe and also classify sedimentary rocks based on those properties. Then we'll go over some of the clues that sedimentary rocks can actually show to explain their past history, how the rock was formed, where the rock was formed. So to start, a little review on the rock cycle. So we have learned that magma or lava can solidify to form igneous rock. So either we have intrusive igneous rock, which forms underground, or we have extrusive igneous rock, which forms at the surface of the earth. Now these are caused by melting. So rock melts into magma. The magma either solidifies underground or it reaches the surface, and that lava solidifies there. So in addition to igneous rock, we also have what we call sedimentary rock. So sedimentary rock is caused by weathering and then compaction or lithification. So weathering, where we have the breakup of other rock, that rock can then be transported, deposited somewhere else. It can travel very, very far distances, or it can travel no distance at all. Over time, it will eventually be compacted and cemented into a solid rock, which we call sedimentary rock. So sedimentary rock is formed by some type of loose sediments. So we are going to go over weathering, the types and classes of sedimentary rocks, some sedimentary structures, and then also sedimentary environments. So the fuel of sedimentary rock creation is weathering. So without weathering and erosion, we would not have the ability to create sedimentary rock. So weathering is the process that breaks solid rock. So this can be either physical weathering or chemical weathering. So we'll go over each of those just next. So weathering creates what we call sediments. Sediments are any loose fragments of rock or loose fragments of minerals that are broken from the bedrock. So you could pick them up. They are loose, unsolidified fragments of rocks. So they could be essentially picked up from the surface of the earth. They can be big, so they might be heavy, but they can also be very, very, very small, depending on the situation and the amount of weathering that the rock has gone through. So for physical weathering, it is just what it sounds like. This is where rock is broken up into smaller pieces or clasts. So whenever the rock is broken into smaller pieces, we call this physical weathering. So I'm going to go through a couple of examples of what physical weathering looks like. I'm going to go through all of these examples here. I have some photos. So the first to talk about is jointing. So this is physical weathering where the rock actually cracks and breaks along cracks that already exist. So there are already cracks within the rock due to changes as the rock was cooling and compressing. And then the rock over time will weather and break along those pre-existing joints or cracks, sort of like fractures. There can also be frost wedging. So if you've ever driven over a pothole with your car, this is what we're talking about here. Water will expand as it freezes. So there might be joints already existing in this rock, pre-existing cracks. As water enters those cracks, if that water then freezes, that water is going to expand, pushing the rock further apart. So the rock will eventually become detached. It will break. This block, for example, can be lifted and pushed out and fall away. So that is physical weathering by water. It's called frost wedging. This also not only breaks the rock, but also makes the cracks worse. So even if there's only a little bit of water entering all the way down here in this diagram, As that water freezes, the crack is just going to continue growing. So this is usually a cycle that every time the water melts and freezes in this rock, it's just going to increase the weathering that occurs. We have something similar that is called root wedging. So instead of water, it's actually plant roots. So small plants and shrubs can begin to grow on the surface of the rock. Maybe there's some soil. Maybe there's some soil that has been caught in the crack. So here is a pre-existing joint in this rock, but you can see that the rock is still attached. Here we have this shrub. So as this tree continues growing, it is going to cause the crack in the rock to expand as the roots of the tree keep growing and push the rock apart. So the roots of this tree, as this tree grows and ages and gets bigger, are actually going to cause failure of this rock here. So it's actually going to break this rock apart. So you can see on this cliff, there are lots of shrubs here, which have over time broken rock along this cliff. And here you see the broken off boulders here. So this cliff side is a result of root wedging. All of these rocks have fallen off this cliff mostly due to these shrubs making their roots deep in the cracks of the rock. Another type of physical weathering we call salt wedging. It's a little similar. Salt is generally dissolved in groundwater, but it can actually precipitate out and grow crystals. So what happens is the crystals of salt will start to grow along the side of a rock. But what this does is it actually pushes on the surrounding rock, causing the rock to actually weaken, and it can weaken very significantly. So this usually happens in more arid and coastal climates, often where you have a lot of sea spray. So along the coast where you are getting a lot of salt splashed up from the ocean water, you have a constant influx of salt to these rocks. The salt formation and the salt continuing to grow along these rocks will cause a lot of weakening of the rock, allowing for increased physical weathering. And then the last type of physical weathering to mention is called thermal expansion. So as things warm up, they expand. So this happens in the ocean. As the ocean warms, it expands. It happens in the air. If you've ever heard that heat rises, that's because warm air is less dense, so it's going to rise up because that warm air has expanded. So that's called thermal expansion. This can actually also happen to rock. So for thermal expansion to occur in rock, the rock has to heat up significantly. So not just a little bit of warmth on a hot day. Usually this would happen when there is something like a forest fire on top of rock. So maybe there is a thin layer of soil and shrubbery that's burning, causing a huge amount of heat to the rock beneath. This can actually cause the rock to expand because it's getting so much warmer so quickly. What then happens is that rock will begin to cool. As that now expanded rock begins to cool, it's going to cause a large amount of cracking, fracturing, jointing, and generally the first layer of rock, so that uppermost layer of rock, will break away completely from the bedrock. So this is not as common. It doesn't happen everywhere, but it can be one of the quickest ways to cause physical weathering. So along with physical weathering, which is where we just have the physical breaking of rock into separate and smaller pieces, we also have what is called chemical weathering. So chemical weathering is where there are actual chemical reactions that are destroying minerals or altering the minerals within a rock. This generally happens when those minerals within that rock come in contact with water or sometimes air. So I'm going to go through a couple of examples of chemical weathering as well. So the first to think about is called dissolution. So minerals dissolve into water. So generally salts or carbonates, but as water is flowing or sitting over your rock, some of the minerals within the rock will actually dissolve into the water. So they will remove from the rock and dissolve into the water. This is going to cause weathering of your rock. As you are removing those mineral pieces, you're removing some of that rock due to the dissolving of those minerals into the water. There's also what we call hydrolysis. So it's not just dissolving, but there are some minerals that will actually react with water to break down. So not just dissolving of salts, but the water will actually chemically react with some minerals. So this can often create then newer minerals. The newer minerals, which are created from the original mineral reacting with water, are generally softer than what they were. So for example, here's a picture down on the bottom of this slide. Feldspar, for example, which is rather strong, can actually break down when it meets water, and it will produce clay, which is quite weak. So it's not just dissolving, but the minerals are actually reacting with the water to become something else. This is called hydrolysis. Since that new material is generally softer, it will get washed away much easier. We also have oxidation or rust. So iron, which is in a lot of minerals, can rust. So when iron rusts, it is turning, instead of into iron, into more of iron oxides or iron hydroxides. So as you can see here, we have pyrite crystals. Remember, pyrite is fool's gold. So the iron within that used to be pyrite crystal has actually rusted out. So you can see there are these empty little caverns where this used to be fool's gold or pyrite. But over time, the iron within that mineral, within that mineral has rusted out. So this one happens generally over a very, very long period of time. Another type of chemical weathering is called hydration. So this is where water is actually absorbed into certain minerals. So there are certain minerals that can absorb water into the crystal structure of the mineral. This is going to cause, for the most part, this causes minerals to expand. This generally will also very much weaken the rock. So the minerals will expand, as you can see here, this photo. There's been a lot of expansion, and not all in the same direction, of these minerals. There isn't necessarily room for expansion, so expanding of these minerals is going to significantly weaken the rock. So the rock is going to become much more densely packed. It is going to try to expand. For example, here, this upside down U shape here is caused by the expansion of all of these minerals from the water. So there isn't room for these layers of rock to expand naturally because they are all stuck in this wall. So what happens is you end up with very weak rock that is trying to fit where it naturally cannot fit. So hydration, you cause a lot of expansion within the crystals of your minerals. This is going to really weaken the rock. So weathering, both types, physical and chemical, generally increases the surface area of your rock. So this becomes sort of a positive loop. As weathering increases the surface area of your rock, you then have more surface area to weather. So weathering increases. What I mean by that is, imagine you had a cube and you were weathering this cube, you would be able to weather all the sides of this cube. However, if you cut the cube into 8 pieces, and then you were to weather these 8 pieces, there is a lot more area for you to actually weather. So instead of just the 6 sides, you can now weather in between all of these 8 blocks. So now imagine if you cut this block into these blocks, into many, many, many more blocks, and then were to weather these small pieces, you could do a lot more damage to these small pieces than you could have when it was a solid block, because the weathering can occur in between all of these different smaller pieces. So weathering increases your surface area by making rocks into smaller pieces, which means there can then be even more weathering, which creates even more surface area, which then allows for even more weathering. So we call that a positive loop. So sedimentary rock, now that we understand how sediments can be formed by weathering, sedimentary rock is formed from those sediments. So it's rock that always forms at the surface of the earth, or very, very, very near the surface of the earth, by cementing together loose grains or sediments. So those grains, those sediments are caused by chemical or physical weathering. So we think of layers of sedimentary rock sort of like pages of a book. And the sedimentary rock layers generally cover the underlying, what we call basement of rock. So there may be igneous or metamorphic rock beneath, but sedimentary rock always forms on the surface. So we might have layers of sedimentary rock covering that underneath basement of rock. So for the types of sedimentary rock, I'm going to go over different types of sedimentary rock before we get into the different situations where sedimentary rock can actually form. So there are 4 types. There's clastic, biochemical, organic, and chemical. So I'm going to go through all 4. Clastic, I would say, is the most common and the one you'll see the most in this class. So clastic sedimentary rock is where we have solid grains that get stuck together in a solid mass. So generally this is formed from any combination of these things. There's going to always be erosion, weathering and erosion. There can then be transportation, far distances, short distances, deposition, so depositing those sediments in a new place, and then lithification, which is the creation of the new rock, or cementation, which is cementing the sediments together to create this new sedimentary rock. So when we look at clastic rock, so remember that clastic rock is made up of other pieces of sediment that have traveled. It can either have traveled huge distances, no distance at all. So learning how to look at these different components of classification will actually give insight into how the rock was formed. So the things to look at when you're studying a clastic rock, or when you're trying to identify a clastic rock, would be clast size. So clasts meaning the individual grains. So for example, here we have a very large clast next to some very small clasts. Also looking at clast composition. So if you can tell what those clasts are made of, are they all made of very dark minerals? Are they made of really light minerals? It's not always very easy to tell. Does it look like it's made of sand? Does it look like it's made of clay? Things like that. Angularity. So are your clasts angular or rounded? So something really interesting about this is you can think, you either can have angular clasts, you can have something in the middle, you can have rounded clasts. So then you can think, well, how did my clasts get so rounded, for example? So if you're looking at a sample of a rock that is very, very rounded clasts, you can assume that those clasts went through a good amount of weathering and rounding before they cemented into that sedimentary rock. So that those sediments may have traveled a good distance. Maybe they traveled in a river before they got to that place where they then cemented into that sedimentary rock. Whereas if you have very angular clasts, maybe those sediments didn't travel far at all. Maybe they fell right off a cliff and then re-cemented over time into new sedimentary rock at the bottom of the cliff. They didn't have a lot of travel because these points, this angularity would have decreased. It would have become a lot more rounded as time goes on, as that rock is weathered more and more. Another thing to notice is called sorting. So within your rock, how are your clasts sorted? Are they very well sorted, meaning they're all the same size, very even, similarly shaped, similarly sized? Or are they very poorly sorted, meaning they have some huge clasts, some teeny tiny clasts, and many in between? And then the last thing to think about is cement character. So the material in between the clasts, what does that material look like? Is it dark? Is it light? Is it a solid color? Does it look like it's a mix of many things? So these are the main components that we look at when we're trying to identify a clastic sedimentary rock sample. So here's an example of, here's some sediment that eventually, they're rather rounded, so maybe they, these sediments were eroded off of this mountain, and then as water flows down this mountain, this here is called an alluvial fan. We're going to get to that later in class. So maybe there was water that caused these fragments to move rather far from this mountain. Not too far, wasn't carried in a stream hundreds of miles or anything, but these sediments have moved a bit. There could then be lithification, which would cause these samples to become, these loose pieces of rock to become cemented into what is now a new sedimentary rock. So we can take a look at our sedimentary rock here and try to determine what is the history of this rock, what is the past story of this sedimentary rock. So looking at the different classifying features, the different things that we look at in our sedimentary rock, we can try and determine and tell the history of this rock. How was this new sedimentary rock formed and why? So in addition to clastic sedimentary rocks, there are also biochemical and organic rocks. So biochemical rocks are made from shells. So there's a lot of organisms that can take ions from the water and make their shells. So that's how they survive. They depend on those shells. When those organisms die, they're going to sink to the ocean floor. They will accumulate on the ocean floor, and they eventually will become sedimentary rock as long as the ocean, as long as they're not in a location that has too much wave action, they will be able to sink, accumulate, and then over time become new sedimentary rock layers on the bottom of that water. So some examples of that are limestone, or what we call chert. Generally, you can tell very much when you're looking at a biochemical rock because it looks like it's made of shells. There's also organic rocks that are made from other living things. So not just shells, but other living things. So this could be coal, for example. Oil shale is another example. So this is where there's actual living shells that make up the material that creates that sedimentary rock. So this is usually plants or algae or plankton, some other living things that eventually die, sink to the bottom of that ocean, that lake, that swamp, wherever they are, And as long as the water is still enough for the cementation process to happen, those living things will then become part of that sedimentary rock layer. So sometimes the organic rocks can be quite obvious. Sometimes you can't tell at all that they are made of organic material. And then the last type we call chemical sedimentary rocks. So chemical sedimentary rocks are formed by when minerals precipitate out of a water solution. So usually they'll have a crystalline structure. So this can be partly formed as the mineral is precipitating out, and then it can continue forming as new crystals are growing. So this can be examples like evaporites. So when salt water evaporates, we leave behind salt. So when the water evaporates, the salt deposit is left behind. So over time, if nothing touches that now evaporated body of water, the salt will grow into a layer of rock. So that will become a layer of sedimentary rock due to the evaporation of this water, leaving behind that deposit of salt. We can also have precipitation from groundwater. So this can be where groundwater is actually causing the precipitation, the lack of groundwater is causing precipitation of these minerals out of the water. So as the water is used up or moved or vacating that area, the minerals within that water will start to precipitate out into a solid. They'll start to solidify, leaving behind layers or areas of these different minerals. And then another type is called replacement. So this is where generally quartz actually can grow and replace original calcite crystals. So an example of this is chert or petrified wood, which I think I have some pictures later in this slideshow, excuse me. This is where quartz can actually grow in place of other minerals. So that literally will replace other minerals that were already existing. So here I have some examples. So here is fossiliferous limestone. So this is made of shells here. It's a layer of rock that is formed and has a large percentage of shells. Here we have travertine, which is a layer of rock that is formed from an evaporated body of water. So here are all the salts that precipitated out of this water. So as the water was evaporating, it left behind all of the solid salts, creating this layer of rock. And then here is chert or petrified wood. So new minerals actually grew in place of the wood that was there. That is called chert.